1.4, we're going to do parametric equations. Now we did a little of this last year, so this year it should be pretty easy. Last year I had to spend like 4 days covering this. And so parametric equations is taking an equation and making two variables dependent upon one variable. So we're used to Cartesian planes and we're used to x and y relationships. Well, in example number 1, we are going to represent a half a parabola. Okay, so we're going to say that x is equal to the square root of t and y is equal to t for any t greater than or equal to 0. And so here the graph is still in the xy plane, but our table of values is different. So the way this works is I have t, I have x, and I have y. So if I start with 0, x is the square root of 0. So I would say the square root of 0 is equal to 0. And y is equal to t. Okay? You see where I'm getting those values from? So the point in the graph, my x comma y, the point on the graph would be 0 comma 0 when t equals 0. So now let's do this again. When t equals 1, my x value is the square root of 1, which is 1, and y is equal to whatever t is, so that would be 1. So at that particular point, it would be 1 comma 1. When t equals 2, oh wait, let's skip that. When t equals 4, then this would be the square root of 4, which is equal to 2, and y would be 4. So again, I've got 2 comma 4. So if I graph this on the xy plane, the lowest value I can have is 0. So my xy plane will look like this. 0 comma 0, 1 comma 1, and then 2 comma 1, 2, 3, 4. And so we have like a half of a parabola. If I were to plug in 9 for t, I'd get the square root of 9, which is 3, and then 9. So my next point on the line would be 3 comma 9. Now, what does that what regular function does that look like? A quadratic, right? Y equals x squared. So if it looks like y equals x squared, is there a way I could show that or prove that algebraically? Now this is the hard part. This is why it took us so long last year when I covered this with the other AP Calculus class. Well, let's start with y, right? So we're going to think in our head, we're going to think y equals x squared. That's what we're going to think. But we're going to start with y equals t. So we're going to start with y equals t. Well, how can I manipulate this situation to change the t to x? Well, if I know that x equals the square root of t, could I square this side and square this side, and then I get x squared equals t? So then the next line would be x squared. So I've got y equals x squared. Do you see the relationship? So what we're doing is y equals x squared is a function where y is a function of x. Y's value depends on x. But in parametric equations, both the y and x value depend on a third variable, t. Does that make sense?
Yeah.
All right. Can we move on to example number 2?